Hey everybody, today we are going to talk about block diagrams and signal flow. So a block diagram is a graphic of a signal path through a device. So this is very broad. It could be basically any electronic or mechanical device described in terms of electronics. It could be digital or analog, and it represents a logic structure. So that's a block diagram. We also have what's called a schematic. And a schematic is a type of block diagram, and it provides super detail in terms of which circuits and which parts are required. So this is really for like servicing a unit, building something from a kit. It's very detailed. And here are the basic components of block diagrams. So we've got switches, open and closed switches, a capacitor. So this is like inside a condenser microphone, we have the two plates. So you can see the two plates there. Lamp, voltmeter, resistor, which constricts the signal coming through it, resists the signal in a certain way. A variable resistor. This is one of the most important things that's used in audio. So this is a resistor that you can change how much it constricts the signal coming through it. So this is like a pan knob. If I pan it from left to right, it will constrict the signal to go in one of those directions. Or a fader to turn the volume on and off. If I turn the fader all the way up, it lets the signal all the way through. If I turn it all the way down, the variable resistor will restrict the signal as much as possible. We don't really use diodes too much, or fuses or cells. Batteries, yes. So this, if you had to look at this and guess, what would you say that it is? A block diagram or a schematic? And in this case, you should say a schematic, because we have a lot of detail on how things are put together, but we don't necessarily see like the logic or like the signal flow in it. So this is a patent for one of the original pickup guitars, some of the first guitar pickups ever. And take a look at this. Do you think this is a block diagram schematic? So we have something over the left, a bunch of arrows going from the left to the right, and then we end up with this. So this is the Dryden wind gust model, and it's an aircraft dynamics model. So in this case, this is a block diagram. It's showing us a concept from basically beginning to end, and we can understand it through looking at this graphic depiction. In this case, block diagram schematic. So we have this is a wiring setup for an Epiphone Sheridan guitar. Got the two pickups. So this is actually a little bit of both, because we have some specific components, like we have ground wires, we have specific pieces of equipment and switches, but then it also shows us from left to right the progress of the signal from input to output. So it's kind of doing a little bit of both. This describes how a computer works, CPU. We have an input, we have different kinds of memory, and that is connected to storage and then output. So this is not a schematic because it's not detailed enough. This is showing the overall concept of how a computer works. So this is a block diagram. I don't know about you guys, I've seen a lot of these kinds of things. Yep. 5-second rule. Here's a block diagram of the song Hey Jude, made by a music theorist. Kind of clever. So the basic question of a block diagram is what are the inputs, what are the outputs, and then what's in between. With in between the inputs and outputs, what controls are there and what changes are there to the signal, what transformers are there. So here's some more symbols and what they mean. This equilateral triangle that's on its side means an amplifier. So it's boosting the signal. There are a couple different kinds. The inverting and non-inverting. So this could take the signal and flip it. Inverting amplifier. So it'll turn it 180 degrees. Non-inverting. If we have a positive and a negative side to the amplifier, then that's a balanced input. So like an XLR cable or a TRS cable, it's an amplifier made for balanced audio. A summing amplifier just takes whatever's put into it and puts them together. So here are some different connections. Unconnected paths just have lines that cross each other, whereas if the paths are connected together, there's a dot. Female circuit boards. So whenever you're looking at a mixer, we'll see something like this where we have a bunch of lines and then a bunch of dots. Those mean that, okay, so whatever's connected to the left side is then connected to here, which you can trace up and down. So it's basically showing us like this stuff connects into this network of stuff that will go to the right. So we have the input stuff on the left and the output stuff on the right. It'll make a little more sense when we look at the example. Tilt this over a little. So controls. These should look familiar. If we go back up here to some of the signals, the variable resistor is this rectangle with the arrow across it, and the arrow being across it stands for being variable. So if you look back for audio diagrams, these two right here, a resistor is the line with the squiggle, and then the straight line again. And a resistor with this the arrow over it means it's a variable resistor. So it's resisting the signal, and you can control on the thing how much signal it resists. So these are pan knobs or just dials. These are faders. These don't tell us what they look like, but it tells us that they're variable resistors that are linked together. So for panning, you have one knob, and it does two things at once. So if I pan it to the left, it turns the left signal all the way up and the right signal all the way down, and vice versa. So inverted variable resistors. So here's what a variable resistor looks like. It's a knob. It's got an input and output. It also has a ground. And this just adds more resistance to the electrical signal coming in. So, like, probably the most important concept in this presentation. A gain switch is a switch that is linking together multiple things. So here's just a reference of a lot of different things that might come up when you're looking at block diagrams. Headphones. Okay, so we also have ground, different kinds of ground. So a ground is, there's a couple different kinds. The basic idea of a ground is that you have a connection to the physical earth, so the ground, and so that if you have any excess electricity, it will go and contact the earth and like be transmitted harmlessly somewhere else. So the earth ground is like the most foundational type of ground. We also have what's called a common ground. So this is like in a cable when you have, let's see, I don't have that. Oh, yeah, I do. Okay, so here's a patch cable, a TS patch cable. So in this case, see if it'll zoom in. Maybe, yeah, there we go. So in this case, it's a TRS patch cable, and both ends have a tip, ring, and a sleeve connection. So tip, ring, go a little bit further back. Get it to zoom. There we go. A tip, a ring, and a sleeve connection. And actually, on these, the sleeve connection is a ground. So it's just a shared connection on both sides of the cable that's linked to this part of the cable, to the shielding. And what that does is it takes any excess signal that could go through the cable and basically puts it onto this part. So it sort of like harmlessly discharges it. So this is a different type of ground. It's an audio common ground rather than something that literally connects to the earth. Got some LEDs and stuff. Okay, so here are some connections. The one that I was just showing you is the TRS phone plug. Yeah, cool. Okay, here's a picture of some EQs, some different types of filter. So we have a high pass filter and a low pass filter. We have some shelving EQs. We're going to talk more about EQ soon in a different presentation. And then we have transformers. So transformers have these matched wavy lines with straight lines in the middle. And transformers can change the voltage of what comes into them, and they can change the impedance, or the strength of the signal, basically. Okay, so we talked about the different individual components of a signal flow diagram, of a block diagram. Let's look at some actual examples and figure out what they are. Okay, so first of all, we have these triangles over here. In this case, they're not amps because they're not on their side. They're upside down. So these are just connections. They don't tell us what it is. This looks like an XLR and it's labeled mic input. So obviously we're plugging in a microphone to something. So this thing, as we just saw, is a transformer. And this thing, as you should remember before because it's the triangle that's on the side, is a transformer. No, it's not a transformer. It's an amplifier, excuse me, it's an amplifier. And because it has a positive and a negative side to it, it is a balanced amplifier. And check this out. The amplifier is connected to this thing. So it's some kind of knob that says gain, 6 dB and 40 dB, and then it has this arrow on it. So that arrow should trigger you thinking about something variable, something you can change. So this is a variable resistor, and it's a gain knob that controls how much this amplifier is boosting the signal. And then we have the XLR out. So what this is just a mic preamp. So it's me plugging a microphone into a mixer, into an audio interface, and boosting the signal, boosting the gain. Okay, so this is a graphic EQ. So we have a ground on the left and a ground on the right. In this case, it doesn't tell us if it's a chassis ground, like a common ground in a cable, or an earth ground. I'm going to guess it's a chassis ground. We've got an XLR input, an XLR output. We have a what kind of amplifier? Balanced amplifier right here. This thing right here is it says level, and then it has a resistor with the arrow. So that is a variable resistor, yes. So then what's going on right here? We have these lines connected together with a dot, and these two open dots with an arrow. So this is a split of the signal. So the signal simultaneously goes to the top half and then to the bottom half. This bottom section is basically the EQ section. And the top section is the bypass, or the signal just going through without going to the EQ. So depending on if you have the bypass switch on, the EQ switched on, the signal will either go straight through here and not through the EQ section, or it will be forced to go through the EQ section down here. So the EQ section being turned off basically controls where the signal's going. We have different filters here, and those filters are basically a bunch of, what are these things? Variable resistors. It's just going to come up over and over again. And the variable resistors control either frequency or how much the gain is being boosted or cut. After we go through the EQ section, we have an amplifier, a transformer, and the XLR output. So this right here is our switch. Okay, so here we have a digital delay. So it's something like this Boss DD3 digital delay pedal, and it's slightly more complicated. So right here, for our input and our output, we have these filters, reconstruction filters, it says. So first of all, this is a digital delay. So at some point, our signal has to go from being analog to being digital, and then back to being analog. So right here, we have these filters. We have a switch. Actually, sorry, not a switch. We have a split where part of the signal goes up here to the top to this thing called this resistor that's labeled mix. And then part of it goes to this whole bottom section and then to mix. So this section up here is just the bypass. So that's the dry signal that's not being delayed or not being affected. This bottom half, so first of all, we go through an amplifier that's controlled by a variable resistor. And then we go into this whole section. And if you look, this section has a loop of the signal. And then it also has, in this section, sort of this breakout thing. So first, let's go through the loop. So we go into our delay section, and it says feedback in and out. So let's come back to that later. A/D. So that's where the analog becomes digital, analog to digital conversion. And then it goes to memory, so the computer component, the digital component. And then we go to digital back to analog. So within this memory, the memory is connected to a delay time select, so how long is it being delayed by? And then that's also being controlled by these variable resistors. So we have this section right here is basically how much is the signal being delayed by. After that section, we go from digital back to analog. So now we're in analog land. We have another split. So part of that signal goes into the mix, and then part of the signal goes in this loop. This loop right here is whenever the signal gets connected back into itself, or the feedback loop, so to make more delays. So instead of just dot, dot, we can have dot, 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 dot. So when it's connected back into itself. So if it connects back into itself, we have two splits. One split goes into the negative side, and one goes to the positive side. And it says feedback polarity, so this is just describing is the fed back signal going to be positive or negative compared to the original? And then feedback level. So how much of the delayed signal are you then feeding back into itself? If you turn the feedback signal all the way up, you'll basically get this crazy feedback loop distortion happening within here. And if you turn it on just a little bit, then you just introduce a little bit of signal back into the loop. So it'll be something like da, da, so all of the way that the delay works, everything that happens to the signal within a delay is contained within this block diagram. And you can understand it if you just examine each component individually, and then you understand the different sections of the block diagram and how the signal flows through it. And this resistor right here controls how much of the affected signal or the wet signal you have, and how much of the dry signal or the original signal you have. You'll always have some of the dry signal. Okay, so if you want to get to know this concept better, try graphing, try writing out your own basic computer setup within your setup. So with headphones, with a microphone, with anything like that, within a block diagram form. So let's do that. I can do that really quick. So I'm going to use my little tablet I have here. in Photoshop. Okay. So let me rotate this. And let's make this full screen. Actually, how do I look at full screen in Photoshop? I kind of never do that. That's okay. No tutorial, I'm good. All right, so basically what I have is I have my microphone. Switch this. There we go. So I have my microphone, and my microphone is connected to my audio interface. So in this case, I have a Focusrite interface, so I'll just call this Focusrite, or Focus in parentheses. So my audio interface, this connection right here is a XLR. My interface is then connected into my laptop. And this connection is a USB connection. Let me switch this over. There we go. So my laptop, so let's talk about my mic going into speakers. So the laptop is then actually connected back into the interface. So this same USB connection. Actually, I think it's best if I do this. So that USB connection can send signal to and from my audio interface, which I'll give as a square here. Yeah, it's so beautiful. So the audio interface also has a different output. So my output here goes to my speakers. But the speakers don't take a USB connection. In this case, I have two XLR connections to go to my speakers. Let's see what else I have going on here. So I actually have two mics. The first mic is my vocal mic. And the second mic I have is a guitar mic. And this is also an XLR. And it's connected into channel 1. So let's see, is there any other stuff that I want to do? Maybe I'll draw a laptop, see how good I am at doing, oh my god, it's horrible. Just doing this freehand looks amazing. Yeah, this is my laptop. Yeah, great. So you get the idea. It's just illustrating from left to right the most basic form of how things are connected together and how things are flowing together. Oh, I didn't put the DAW in there. Yeah, let's leave that out for now. So do this with your own setup, and you'll understand the way it's put together better. So there's some more practice here. This is a part of a mixer. Switch this over. Actually, I'll just put it in the middle. So on the left, we have a variable resistor controlling an amplifier, a whole EQ section, This section goes to soloing or to pre-fader listening. Then we have a variable resistor for the fader, a variable resistor for the pan control, and here we have a bunch of splits. So the mix bus goes from left to right. So if we follow this connects to left, and left then connects to this left output fader, and then to the modules. So right here, this is where we go from a single channel of input to then a single channel of output. So we can trace everything that happens with the signal from whenever we plug it in or whenever we send it in to whenever it comes out. Okay, this is a little more complicated. So in this case, we have all of our inputs up in this top section that are connected to a snake. And then our snake is connected into our house console or into our mixing board. The mixing board is then connected to a bunch of stuff. So it's connected to some effects that loop in and out. And then it's connected to the main outputs, so our big speaker system, our PA system, and then to our monitor outputs, or the speakers that are on stage. So we basically have three big sections: inputs, the different kinds of outputs, and our mixing section. This is a way simpler version of the same exact thing. We have all of our inputs. We're using auxiliary or aux outputs or buses to send to our stage monitors up here. And then we're using our master output to go to our main outputs. Okay, so that's the basic idea of block diagrams and signal flow. To get this, you basically need to get your hands on some block diagrams of equipment you're using or equipment you want to use, and spend some time looking through it and understanding how it works. If you really want to know, you can get a build your own mixer, build your own speaker, build your own amplifier kit, and work on building it from the individual components just using the block diagram as a reference. Yeah.